the 2022 AP Calculus AB free response questions number 1. Let's take a look at the first question. From 5 a.m. to 10 a.m., the rate at which vehicles arrive at a certain toll plaza is given by A of t equals 450 times the square root sine of 0.62 t, where t is the number of hours after 5 a.m., and A of t is measured in vehicles per hour. Traffic is flowing smoothly at 5 a.m. with no vehicles waiting in line. So at this point, if you would like, you can pause the video, take a look at A, B, C, and D, and see if you could answer this question on your own. Now, if you're here for help, what we're going to do in this video is break down each part and how we should approach this problem. So let's jump into part A. Write but do not evaluate an integral expression that gives the total number of vehicles that arrive at the toll plaza from 6 a.m., which is time t equals 1. As a reminder, t is the number of hours after 5 a.m., and then to 10 a.m., which is t equals 5. So we don't have to evaluate. All we have to do is write the integral expression. Now, for the total number of vehicles, how are we going to do that? Well, we are told that A of t is measured in vehicles per hour. So A of t is a function that gives you a rate for an output. So it makes sense to need an integral in this case because we're going to basically be accumulating cars per hour in order to determine the total number. So what we can say is the total number of vehicles that arrive from 6 a.m. to 10 a.m. is given by, and we're going to write that integral that would make that calculation. So we're going to integrate, once again, because we need an accumulation of the vehicles per hour over a given time frame 1 to 5, and we are given a function that determines a rate at a specific time. So integrating from 1 to 5, we can write A of t dt. We do not have to evaluate. That's all there is to do. And we have a 1-point question here where we just have to write that integral. Now, we could substitute in the actual function for A of t. So if you would prefer, just make sure you copy down the function correctly, where we can say 450 sine 0.62 t dt. So acceptable to do that as well. So there's your part A. So let's jump over to part B. Find the average value of the rate in vehicles per hour for which the vehicles arrive at the toll plaza from 6 to 10. So same time frame, now we're determining average value. So what are we finding the average value of? It tells you to find the average value of the rate. And the good news is they give you a function that determines the rate. So we need to find the average value of that function A of t over that time frame. And if you recall, your average value formula is the length, or you're going to find the integral along that time frame. So we'll just say in general, we have from a to b of our function f of x dx, and all we have to do is divide by the length of the interval. So now, carrying that over to this specific problem, the average value, or the average rate, is going to equal 1 over 5 minus 1, where 1 and 5 are a and b respectively. So we're going to integrate from 1 to 5 of the function A of t dt. Now this, we actually have to make the computation. It does ask you to find the average value. So we're going to be going to our calculator here. And one thing to take note of before we make this computation is we are dealing with a trig function in this problem. So we should have our calculator in radian mode for the AP exam when working with trig functions. So we're going to have 1 over 5 minus 1. So the computation we're making, 450 square root of sine 0.62 t dt. And when we make that computation in our calculator, we're going to get 375.537 we're rounding to 3 decimal places, so you would get an answer that extends beyond those 3. So just remember to round to 3 decimal places in a situation where a computation leads to more decimal places than 3. So let's interpret our answer here. This value represents the vehicles per hour on average along that time interval. So this is our average rate. So this is a 2-point part question here. You're going to get 1 point for recognizing the correct average value formula, which we're doing up here. And then you're also going to get a point for your answer. So now let's jump over to part C. Part C, also a 2-point question. Here we have, is the rate at which vehicles arrive from 6 a.m. at time, or I should say, is the rate at which vehicles arrive at 6 a.m. or time t equals 1 increasing or decreasing, and give a reason for your answer. So anytime we're trying to evaluate whether or not a function is increasing or decreasing, that's going to come down to evaluating the sign of the derivative at that input value. So we'll know it's increasing if the derivative, so we're going to be working with, we're trying to determine is the rate increasing or decreasing. So we'll be working with that given function a of t. So if the derivative is greater than 0, we'll be increasing, implying a positive rate of change. And if the rate of change is negative, we would have a decreasing function. And we have to evaluate it specifically at the point time t equals 1. Once again, we have a calculator to make this computation. So we'll get a point for recognizing we need to evaluate a derivative here. So we want to know, what is a prime of 1? So in our calculator, we're going to be doing ddx of 450 sine of 0.62x at x equals 1. This is what it'd look like in our calculator, but we are differentiating with respect to time. So to keep things consistent, this is what our evaluation is going to be. And upon the correct evaluation, again, make sure it's in radian mode, we'll get 148.947. Now, we got our answer for the derivative at that specific time. We see that that value is greater than 0, so we can now give a reason for our answer. So we can say, because a prime of 1 is greater than 0, a prime, or a at 1, is increasing. Or if we don't want to just say a of 1, we can say a little more detailed answer here. The rate at which, this is probably a better answer, vehicles arrive at 6 a.m. is increasing. So once again, we're going to get a point for using the derivative, and then we're going to get a point for our answer with the reasoning. So now let's move on to the last question. A line forms whenever a of t is greater than or equal to 400. The number of vehicles in a line at time t for a is less than or equal to t is less than or equal to 4 is given by this function n of t, where a is the time in which, or when, a line first begins to form. So that's going to be important there. So we don't have a value for a right now, but we know it's when the line first begins to form. And when does a line start to form? Whenever that function a of t is greater than or equal to 400. So to the nearest whole number, so another thing we want to pay attention to, our final answer, we're going to have to round that. Find the greatest number of vehicles in line at the toll plaza in the time interval a to 4. Justify your answer. So what computations do we have to make here? Here's the key right here. Find the greatest number. So that implies when we want a greatest or a smallest, something like that, we have an optimization problem. And specifically, we're going to be looking for a max. Now, to find a max, we can use our derivative tests. So we're going to be looking at the derivative of n, because that function of n tells you the number of vehicles in line at a certain time. So we want to know what the greatest number of vehicles in line. So vehicles in line, number of vehicles in line, we're going to be looking at this function or analyzing that function. So now, when we're trying to determine where this max could possibly occur, we're going to need to find the critical points of that derivative and also consider these endpoints because they give us a closed interval on which to observe. So when we make our sign chart for our first derivative, it's going to have to extend from a to 4, and there might be some critical points in between that we're going to take a look at. One other thing to note, along with rounding our final answer, is we don't want to just end the problem where we find the time when it would happen, because it's asking find the greatest number of vehicles. So once we know when it happens, we're going to have to evaluate the function n at that time to determine the greatest number. Okay? So how are we going to find these critical points? Because we have a calculator question, let's first take a look at the derivative. We're going to use the graph of that derivative. Taking the derivative of n is not difficult. We know a is a constant. N is defined in terms of t, so our upper bound is a variable or a function itself. So using the fundamental theorem of calculus, taking the derivative, this thing's already set up for us. We're just going to substitute t into the function and then multiply this function by the derivative of t using that chain rule, but the derivative of t with respect to t is just 1. So here's our derivative function. We want to know when we have critical points, which is when this would equal 0. We don't have to worry about when the function's undefined in this case, because a of t is a continuous function along this interval. Shouldn't be any problems here, and we can confirm that from the graph. So this is all we're looking for, along with, so when does this happen, along again with the endpoints that we'll have to take a look at. Now we can manipulate this a little more. So we can say we want to know, well, when does a of t equal 400? And isn't that nice that that's an observation we're making here, because we also know that whenever it's greater than or equal to 400, a line is going to begin to form. Now, when we plug in this function to our calculator to graph it, so we're going to y equals, and we're going to graph this function here. I'm going to manipulate the window, the x-axis, so that it's just extending from 0, we're not going to go into negative time, up to 4. And when we do that, so we have our x-axis, you would see something that looks like, we have 1, 2, 3, 4. We're going to see something that looks like this. And it's going to probably get cut off depending on how high your y-axis goes. So we can see the zeros are going to answer this question here where our critical point is. So we're going to calculate on our calculator where these points are. And we're going to determine that those time values are going to be, so there are the two time values where we're going to get x-intercepts. All right, now, how do we continue our analysis here? Well, one thing we don't know right now is what the value of a is. And I now have these two new numbers that represent critical points. But as we said before, these two functions here, a of t minus 400 equals 0 and a of t equals 400, are the same. So instead of the x-axis being represented here, we can say that horizontal line would be 400. Okay, so if we just make that comparison there where those functions are the same, we should get the same points of intersection at that same point in time. So what does this mean? Well, we were told that whenever the function is greater than 400, so if this is our line of 400, then the line is going to start to form. And the line begins to form at a. So it must be true when I look at this function, this part of the graph that I'm outlining in green is when A of t is less than 400. And then that first x-intercept there, or that first intersection point with 400, it's not an x-intercept anymore if I'm redefining that x-axis as a value of 400, this must be our value of A. And that value of A is therefore this first time value that we find. Because right after that, we can see that the function is now greater than 400, and therefore the line is now beginning to form. So we can substitute that value in for A. Now, that other time value we can see does fall inside of our sign chart here. We're going to put that roughly around 3.59. And we can also analyze the sign chart to determine when we have max or mins. So because this graph is my derivative graph of that function of n, or n of t, I can see that after that first initial point A, that graph is above the x-axis. So our derivative function, which is this sign chart is going to be representing, we have a positive interval from that point A to 3.59. Then it goes below. So then it's negative. So what does that mean for our function n of t? That means it must be increasing from here and decreasing there. So what does that mean for what these critical points represent in terms of optimization or extrema values? Well, because it's increasing from A, that must be a min. Because the function transitions from increasing to decreasing, we have a max. And then it decreases to 4, which means this is also a min. So because we're trying to find the greatest number of vehicles in line, we now know that that's going to occur at this time. That's the only eligible maximum value along this interval from A to 4. So once again, we figured out where it happens, but now we need to just fully answer the question here and determine, well, what is the greatest number of vehicles now that we know when it occurs? So we're going to have to evaluate this function at this value. Okay, so we know the max occurs here. We can use our calculator to make this evaluation. We discovered what the value of A is. So we're going to compute the integral from that value of A, which is 1.469372, all the way up to 3.597713 of A of x, which is 450. Let's make sure I copy this down right. Square root of sine 0.62 minus 400. And this is in terms of x in this case, dx. So this is the computation we're going to make now to determine what this max value of vehicles is. And when we make this computation, we're going to find out that it comes out to be 71.254. So this is telling us at this time, this lower bound of the integral was the value of A when the line first begins to happen. We determine that by analyzing the derivative graph and recognizing that the derivative of n is A of t minus 400, and finding the critical points, A of t minus 400 equals 0, revealed that that was synonymous with A of t equals 400. And we know once A of t equals 400, the line begins to form. We analyze the graph instead of trying to compute the derivative by hand, because analyzing the graph can be easier and less room for error. We let the calculator do it for us. And to finish off this problem, don't forget, as we stated before, we need to round to the nearest whole number. So that would be 71. So what we have determined is that the maximum number of vehicles, or the greatest number of vehicles in line, is 71. That is specifically on that interval from A to 4. So, what's the point breakdown? We're going to get 1 point for considering the derivative of n. Why did we consider the derivative of n? We recognize this is an optimization problem, trying to find a greatest number of something, and that function n gives us the number of vehicles in a line, so we want to know when it's maximized on that time interval. So we use the derivative. Then we also want to know when that equals 0 to find those critical points. So the derivative equals 0 at some point in your answer is going to get us a point, that consideration. We're also going to get a point for finding those two time values when we analyze the derivative. So that 1.46 value and the 3.5977 value, finding those two things are going to get a point. The answer is going to get us a point, and then a justification is going to get us a point as well. So there is the first question on the 2022 AP Calculus AB exam.